To explain why it's necessary to build a proper UV projection for our objects, it's useful to think about a real-world sticker and the problems we have sticking it on several different objects. You will be able to stick those onto a flat surface, but you will run into problems when you try to stick your sticker onto a sphere. UV is a must-have. A texture won't work on an object without a specified UV projection. You can check this by importing an older DXF object. The older DXF file format wasn't able to track the UV projection from any CAD program because it simply wasn't important. If you try loading one of them into trueSpace and painting this imported object with a texture, nothing will happen because of the missing UV projection. trueSpace automatically generates a basic projection for the library of primitive objects. You can see that our cube shows a real-time preview of our basic projection. Category uses a base cubic projection for cubes, of course. We have to check out what projection we should use for our object by learning the basic UV mappings. trueSpace offers some basic projection methods and some for the advanced UV projection. You will learn to use them in this tutorial. The result of any projection is a map. The assigned map defines the UV projection for any surface. To map our simple object, we will use simple projections. These are planar projection. This is useful if you want to project a texture like a torch. You can see how the real-time preview tracks these changes when I move the UV cage. The torch example isn't perfect because the projection is applied to the back of the object too, but it's just to show you how the 3D and the real world sometimes fit and sometimes don't. The cubic projection. To describe this, try to imagine a simple paper box. When you unfold the box, you see 6 sides. trueSpace uses it the same way. It unfolds any object to 6 sides and applies the texture onto it. It's now as if 6 torches light the object. I hope you can still follow my examples. You will see that's even going to be harder. The cylindrical projection. This is like a sticker around a can. Top and bottom will not be affected in reality, but in 3D any face needs a UV. So the unaffected faces will be filled with undefined pixels. The spherical projection. If you think of a balloon instead of a sticker and try to light it with a torch, you can see how the cube inside the balloon interacts. You can see that some faces flip and stick sometimes. This is a well-known problem, but I'm not going into details of this matter here. The shrink wrap. This is useful for the extended projection and I will explain it with some more examples later.